In our last class, we studied how to solve equations that were exponential equations. In this class, we'll be solving logarithmic equations of varying difficulty. Here we have the agenda. If you want to pause the video and read through that, I recommend that. So we'll just kind of break it down into solving single logs and then move on to more difficult equations that have multiple logs in it. We're also going to do a little error analysis, and later on move on to our mastery questions, and last there will be a extra credit worksheet that has logarithm problems on it, and it's a maze. Next is a slide just saying a little bit about an example of where logarithmic equations are used. The example is of earthquakes and the Richter scale, which is a logarithmic scale because of how powerful earthquakes are. The magnitude 5 versus a magnitude 6 versus a magnitude 6. Those magnitudes of power are actually like increasing exponentially, and taking the log of those magnitudes makes the numbers a little bit easier to deal with. So in science, there are some certain cases where we would switch to a logarithmic scale. Here's a couple steps for solving logarithmic equations. First, you want to use the properties of logs to condense the expression into a single logarithm. Sometimes you'll be given an equation that you don't need to condense, and you can just jump to solving it or jump to the next step, but sometimes you will need to condense. So our first problems we won't have to condense, but after that, after the first couple examples, we move on to some more complicated problems. Secondly, we want to rewrite the equation as an equivalent equation in exponential form. So we're going to be using our properties here. So if you get a little bit confused about what I'm doing, just recall I'm switching from log form to exponent form. Next, we can solve for the variable. And then we always want to plug in our value that we got when we solved and just make sure that that is true. Moving on to the teacher model, we want to solve this logarithmic equation. On the right hand side are some guiding questions that you can use. First I'm going to look and say, do I need to condense this? Well, no, I don't, because there's only one log statement. So we can kind of skip over that. Next we want to see, is there any way that we can rewrite this equation? It looks like nothing's going to cancel out, and I'm not going to give you guys equations where they're that simple, but we're going to want to move on to rewriting the equation so that we do not have a log. So using my properties, I see that our base is going to be 4, this is going to be, the exponent is 2, and then that's going to be equal to our argument right here. So I'm going to rewrite this as 4 to the power 2 equals x plus 3. Simplifying that, we know that 4 squared is 16, so that's equal to x plus 3. And then at that point, we're really just isolating x, so we want to subtract 3 from both sides of the equation there. We get 13 equals x for our solution. We do want to make sure to check this. Remember that the argument of a log needs to be greater than 0. So we're not supposed to take the log of 0 or of a negative value. And so we want to check on that answer that we got and make sure that when we plug 13 in for x, that we don't end up making our argument a number that's negative or 0, and of course that's not the case here. And I can confirm that log base 4 on 16 would be 2, so this does check out. and it turns out that we do not have any extraneous solutions. But if we had gotten an answer where when we plugged in our number and it turned out that our argument was a negative or it was 0, that would be a case where what we solved for was actually an extraneous solution. Moving on to the WeDo, I would encourage you to pause this video and go ahead and try it on your own, and if you get stuck, use the guiding questions, and then if you still are not sure what to do, go ahead and play the video and catch the rest of this being solved. So moving on, do I need to condense this log? And we do not need to condense the log since it's only in one spot. So we want to use, or we don't need to use the properties, but we do want to use the property where we rewrite the equation so that we can get rid of that log and maybe just work with an exponential equation, since we have already learned how to solve those in the previous lesson. So looking at that, we see that the base is 2 and our exponent is on the other side of the equation, so we have 2 cubed is equal to x minus 4. We want to go ahead and simplify that cube, so 2 cubed is 8, it's equal to x minus 4, and then we want to isolate the x, so that means we want to add 4 to both sides. Simplifying, we get 12 equals x. Of course, we would want to check on that, and so if I think about plugging that back in to the equation just to check it and make sure that we don't have an extraneous solution, we would see that we would get log base 2 of 8, and that would be equal to 3, so that checks out, and we don't have any extraneous solution. Moving on to the WeDo plus, if you feel like you understand this process, then you can go ahead and skip ahead to the UDO, and if you want to see another example, just stay along, or I actually recommend that you pause the video and attempt this, and then play the video to see if you got it correct. So first thing, I don't need to condense the log, there's only one of them, so we want to jump to rewriting this equation so that we don't have it in log form. Our base of the log is 4, that means that's going to be the base of my equation, and doing the log on something gives us the exponent. So 3 is our exponent here, so 4 to the 3rd power is going to equal the argument, which is x plus 5. So let's go ahead and simplify that. We've got 4 to the power 3, that's going to be 64 equals x plus 5, and we're at the last step, isolate x by subtracting 5 from both sides, and that's going to give us 59 equals x. For our final answer, go ahead and do a check on this just to make sure you don't have an extraneous solution. This one's kind of obvious that it's not, but it's good to get in the habit of doing that, so we can see, oh, we get log base 4 of 64, and yeah, that would be 3. Okay, so at this point, go ahead and move on to the UDO, which is the worksheet problems, and attempt that section.